All right, you remember from part one, our problem was to find the slope of the line tangent to this function at x is equal to 3. So here's our function, the blue curve, the parabola, and we want to find the slope of this black line that is tangent to the curve, just barely touches this curve at that one point. All right, we've been doing slopes for years and years, ever since about the, 6th, 7th grade, whatever. This shouldn't be a problem. Well, we did have a problem, as you remember, because we only have one point. And we sort of abandoned this particular problem and decided to go down a different rabbit hole. So what we did was approximated this, found the slope of a different line, not our black line, but a line that goes from x is equal to 3, right here, 3, 1, to 5, right here, x is equal to 5. We found the slope of this, which is an approximation for the slope of the black line. So we did that. Then we decided we could do better than going from 3 to 5. We went from 3 to 4, found 2 points, worked it out. Each time we got 2 points instead of just 1 point. And our approximation was a little better the second time than the first time. Then we did a couple more. Finally, we found the slope from x equal to 3 to 3.013. Found 2 points, worked it out right here, worked it out right here, and got this slope, which is a really good approximation, probably work in most situations, but it's not our slope. Okay, so now let's see what we can do here. Each time we have started with 3 and found another point to accompany 3 that added something to the 3. So this time we're going to do the same thing, but so we're going to say let's go from x equal to 3 to x is equal to a little bit, and we'll call that little bit h. So once again, we got 2 points. That's the real key. We got 2 points. So 3 comma f of 3, and then 3 plus that little bit, 3 plus h, f of 3 plus h. So here are our 2 points. The slope, like always, rise, change in y's, over, run, change in x's. So right here, we did a little bit of algebra, simplified it to this, a little bit more algebra, got to here. Now let's see what we can do here. Got a bunch of things added and subtracting, so let's combine like terms. Let's see, 7 minus 1, that's 6. 18 minus 24 is negative 6. So negative 6 plus 6 adds up to 0. They don't cancel out, they add up to 0. And then, or at least in our class, they don't cancel out. All right, we add these and you get 4h and then plus 2h squared all over h. All right, golly, we still can't find the slope, and we'll never find the slope really until this little bit of difference is 0. And we'll have a real problem then because we can never divide by 0 in math class. All right, so let's do something real creative that we're going to do a lot in calculus class. We're going to do something called, we're going to take the limit of this expression right here as h approaches, as h gets closer and closer to 0, and see what happens. One of the things that we'll learn about limits is we can take this number and put it in place of that variable. That's going to be a problem here because we'll still have 0 on the bottom. So let's see, what can we do? All right, so on top, I'm going to factor out an h. And I still have the limit, but I'm going to abbreviate limit this time, LAM. So we got the limit of this expression as h goes to 0. Now, the h's don't cancel, but h over a, in our class, h over h is 1. So I have 1 times 4 plus 2h. So that's going to be equal to 4 plus 2h. Now, we can take the limit of that. We still have not taken the limit. So take the limit of this as h goes to 0. So as h goes to 0, this is getting closer and closer and closer to 0. 2 times that number is getting closer and closer to 0 is getting closer to 0. So 4 plus some number is getting closer, 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 is getting to 4. So we can say now that the slope of our black line, the slope of the tangent line, is, by granny, 4. Our math forefathers and foremothers have basically given this to us and called it the definition of derivative, and we worked it out. Okay, so in general, follow me, Miss Camerawoman. If we have this problem, find the slope of the line tangent to g of x. We had f of x a minute ago, whatever the function is, at some number. I'll just call it x is equal to a. Or, just a different way to be asked the same question is, given g of x, find the derivative, real important word in calculus class, of g of x at x equal to a. Or, the same thing is, given g of x, find g prime of a. Now, how are we going to do that? Well, our deal here is we are always going to start with 2 points. What are our 2 points? Well, one's really easy. Our x value is a, and the y value or the g of x value is g of a. Our next point is a plus a little bit. We'll call that little bit h. And then the y value would be g of a plus h. Find the slope. We got 2 points. Find the stinking slope, like we've been doing forever and ever. So that'll be the change in y's over the change in x's. All right? So now, is this the slope of our tangent line? Is this equal to g prime of a? No, it is not equal to g prime of a. This is just the slope of the secant line from x is equal to a to x is equal to a plus h. So what we can do here is just say that this is an approximation for g prime of a. Now, if we come down a step, take the limit of this, I think I'll go ahead and do a little bit of algebra on the bottom. Combine like terms. A minus a is 0. So 0 plus h is h. So now, if I can take the limit of this as h approaches 0, then I can say that that, by granny, is equal to g prime of a, which is the answer to any one of these 3 questions. So, what we have here is the definition of the derivative. Probably the most important definition in all of calculus. And I maintain you don't have to memorize this. All you got to think about is 2 points and basically do what you have done for years and years and years.